The overall goal of this procedure is to create a multifaceted environment to support nerve growth and repair. This is accomplished by first encapsulating growth factors within degradable microspheres. The second step is to prepare the support material for the bulk of the environment. Next, the microspheres and support material are combined and electrospun into an aligned fibrous scaffold. The final step is to test the scaffold with chick dorsal root ganglia neurons. Ultimately, immunofluorescence microscopy is used to show that neurite growth and direction is accelerated compared to controls.
Though this system is designed for neural tissue, with slight changes to the proteins and materials used, it could also be applied to various tissue types, including hearts, lungs, and bone.
Prior to starting this procedure, prepare the necessary reagents. 2% and 0.5% weight per volume solutions of polyvinyl alcohol, or PVA, in deionized water, a solution of 2% volume per volume isopropyl alcohol in deionized water, and an aqueous solution of the desired hydrophilic protein. Place 40 milliliters of the 0.5% PVA solution into a 50 milliliter centrifuge tube and set aside. In a small vial, dissolve 300 milligrams of 65 to 35 polylactic co-glycolic acid, or PLGA, in 3 milliliters of dichloromethane. A vortex mixer can be used to accelerate PLGA dissolution. Combine 200 microliters of protein solution and 4 microliters of 2% PVA solution. Pour the protein PVA mixture